Imagine a world so hot that the ocean felt like a bubbling hot tub. Massive volcanic eruptions had flooded the atmosphere with carbon dioxide, and with the continents fused together, stretching from pole to pole in the supercontinent Pangaea, Earth became blistering, flat, and desperately dry. Ancient reptiles and the ancestors of mammals still thrived in this harsh land, ruling over a world that was still struggling to recover from the mass extinction at the end of the Permian. This was Earth 250 million years ago, at the dawn of the Triassic period. But then, beginning around 234 million years ago, the climate shifted abruptly. The rains finally came to this parched world, and they did not stop. For nearly 2 million years, relentless downpours drenched the land. This era of intense rainfall wiped out many of the early reptiles and left behind layers of sediments that would puzzle geologists hundreds of millions of years later. Today, it is known as the Carnian Pluvial episode, a turning point that cleared the way for a new group of animals to rise, the dinosaurs. Evidence of just how hot and dry the early Triassic world was can still be read beneath our feet. Rocks from this time are mostly bands of red sandstone and arid soils, with no trace of the coal swamps that had once blanketed Earth through much of the Permian. One major reason for this desolation was the shape of Pangaea itself. With all the landmasses locked together, rain clouds could not easily penetrate inland, and there were no major mountain ranges to break the monotony of the dry continental expanse. Dinosaurs did exist in this post-Permian world, but they were far from dominant. They struggled for a foothold against other reptiles and the distant ancestors of mammals. At the time, the top carnivores were crurotarsans, a broad group of crocodile-like creatures that included pseudosuchians and phytosaurs. One of them, Ornithosuchus, had long hind legs and could rear up to run, a sight that would have been both awe-inspiring and terrifying to behold. Even stranger were the rhynchosaurs, squat herbivores with parrot-like beaks and sometimes outsized cheekbones, carried on lizard-like bodies. And though true mammals had not yet appeared, there were dicynodonts, the closest relatives to mammals alive then. Despite their scaly hides, tusks, and beaked jaws, these creatures were actually more closely related to us than to Dimetrodon. Dicynodonts were widespread through the Triassic, with one species in particular, Lystrosaurus, becoming so abundant across the globe that its fossils later helped shape the very idea of plate tectonics. Yet these creatures, so well adapted to a dry climate, were about to be challenged by something unprecedented. Much of what we know about ancient climates comes from plant fossils and the rocks they were preserved in. In the early 1990s, two British geologists came across layers that didn't fit the Triassic's dry profile. Instead of thin deposits of red sand, they found thick sediments from vast lakes and clear evidence of coal swamps, all pointing to a prolonged period of rainfall that lasted nearly 2 million years. What was strange was that traces of this wetter climate turned up everywhere. From England to the Americas to Israel, regions separated by thousands of kilometers. This proved that the rainfall must have been global in scale. At first, many geologists were skeptical, suggesting it could be explained by local flooding. But over the next 2 decades, more and more evidence emerged, pointing to a world that had truly endured a period of extraordinary rainfall. The rocks told the story. Coal deposits in Austria, ancient lakes in Italy, wet soils in Utah, and even massive rivers in China, all of them dated to the same window of time, between 232 and 234 million years ago. This phenomenon would later be named the Carnian Pluvial episode. Carnian refers to the geologic age within the Triassic when it occurred, while pluvial means heavy rain. One estimate suggests that annual rainfall in what is now Utah nearly quadrupled, peaking at about 1,400 millimeters, comparable to a temperate rainforest. And this wasn't a one-time flood. It was relentless, year after year, across the globe for 2 million years. The result was inevitable. The world had to change. And the greatest change was the sudden rise of the dinosaurs. At the start of the Carnian Pluvial episode, dinosaurs accounted for only about 5% of terrestrial vertebrate fossils. By the end, they represented over 90%. The question is, why did they suddenly flourish? Perhaps it wasn't because they were inherently superior, but because the food supply shifted in their favor. With the rains came towering conifer forests that replaced the soft ferns and low shrubs of the drier world. Rhynchosaurs could only feed on plants close to the ground, while dicynodonts, lacking teeth, struggled to process woodier plants. In contrast, herbivorous dinosaurs had both teeth and the ability to swallow stones to grind up tough vegetation. Fossilized dung even shows their droppings contained as much as 85% wood. As the vegetation changed, dinosaurs gained a decisive advantage, while their rivals faded. Predators like the crurotarsans also declined as their prey disappeared, leaving dinosaurs as the only large reptiles able to thrive. But what kept the rain falling for 2 million years? The answer lies in the Wrangelian eruptions, a series of massive volcanic events in what is now Alaska and British Columbia, beginning around 235 million years ago. These eruptions lasted more than 5 million years, producing lava layers up to 6 kilometers thick and releasing enough carbon dioxide to raise global temperatures by 3 to 10 degrees Celsius. Warmer conditions fueled a faster water cycle, driving more rainfall. This is why the Carnian Pluvial episode is sometimes also called the Carnian Humid episode. After roughly 1 million years of heavy rains, volcanic activity slowed, and Earth's carbon cycle began to stabilize. Plants stored carbon in their tissues, rocks absorbed it through weathering, and the oceans locked it away as limestone. As atmospheric carbon dioxide declined, the climate gradually returned to arid conditions by the close of the Triassic. Yet even though it lasted only 2 million years, the Carnian Pluvial episode reshaped Earth forever. Conifer forests spread across the land, dinosaurs rose to dominance, and the world entered the age of these giants. Thank you for watching today's video. If you enjoyed this content, be sure to like and subscribe for more.